Hi everyone, welcome back. We continue on this list and today we are going to learn about log function. This function, the usage is very simple. You are just giving the input image and it's gonna give you the destination image. And inside the pixels of this image, all the pixel values will be applied the natural logarithmic function and the results is gonna be given at the output of the destination image correspondingly. And why we need this function, maybe we can talk little about that one. As you can understand, since the natural logarithmic will be applied to all pixel values, it's gonna decrease the value. So in image processing, especially when dealing with the images captured in challenging conditions, challenging lighting conditions, the pixel values may change in a wide range. So applying this OpenCV logarithmic function to the pixel values, to all the pixel values inside the image, can compress the dynamic range, making details more visible and maybe enhancing the certain features in the input image. So maybe in that case this can be useful. Also in the same way, in the same logic, you can also use this function for noise reduction because it's just decreasing the values, right? It's just decreasing the dynamic range of the pixels inside the image. So in these cases we can need this function. Okay, maybe we can switch to the code part and continue accordingly. In here we already have an example from the previous video. We can just remove this part, and first of all, also we need to give the float type of image to this logarithmic function. So we need to change this as float because before this was unsigned char. And maybe this is input 1 image. First of all, I want to apply to this one. Since this is gonna give the float type of output, we cannot see the results in the im show, so this is not useful now. Maybe we can directly call the function. First of all, we are gonna give the input 1 and the destination image we needed. Let's define that one also. This is gonna be destination, and see the result in the console. So let's write this. Okay, and it's done. Let's see the result. Im show is nothing because it's float type. We just need to focus to console. In here it's giving the output accordingly. This is the calculator. Let's try it's giving the correct results or not. This is the ln function. Where is logarithmic ln? Okay, and let's try 188 and see the result. 5.23. so it's correct. In here you see. Similarly, let's try the one more. Maybe how to delete this one. Okay, ln 77 is equal to 4.34, which is correct. Okay, so this is just basically applying all the pixel values this ln function. What if we want to apply to a normal image, which is in here? You see Lena image. Maybe we can apply to that one also, but it's needed to be a float type. So first of all, we need to convert it to the float type of image. Maybe we can change here in and out. Maybe we can also try to see by converting to unsigned char at the end. Okay, this can stay for now. First of all, we need to define a new method, and this is gonna be float image. Since our Lena image is unsigned char type at the beginning, so we need to convert it to the float type. We already learned the convert to function from our previous tutorials, and here we need to give just the output, which is float image, and the type, what this is gonna be is 32. Float is gonna be enough, and now we have our float type of image, and all we need to do is that calling this float image, and maybe we can the name again log image, and after that we are gonna get that one. Okay, now we get the logarithmic of this input Lena image in here, and how to visualize that one. We can convert it again to the unsigned char, to the result, maybe result image we can call it, and calling again the convert, but with that we can use log image dot convert to it's gonna be the output result image, and the type is gonna be 8-bit unsigned chart. Okay, and we can visualize with imshow now, because both input and the output is on the unsigned chart part. And here, okay, and it's gonna be image and in and out. Okay, let's see the result. Okay, this is my output and this is the input, which is Lena image. You see nothing, but you can understand the pixels is meaningful. They are not totally zero, because when you apply the Lena image, when you apply logarithmic function, it's just decreasing the range. You can see in some cases you see 4, 3 maybe, because all the image is dynamically compressed to a really lower range. So in here you see a wider range from 79 to 255 maybe in some cases, but here it decreased to the smaller case. By the way, these are unsigned charts, but in the reality they are in float type. Maybe they are even so small kind of differences, they are different than each other. We just see in here the rounded values we see here. Yeah. One more thing maybe we need to check. We can check, by the way. And what is that? This is float, we already know. This is float type, and this is also float type, log image output. We can apply exponential function, because we already learned that, right? This is the fourth one, is which we learned before. And let's call it and put our log image output, because if you apply something which is output of the logarithmic, natural logarithmic function, if you apply exponential function to that one, it needs to be given the same result of the input. So what we need to do is just logarithmic image and exponential output, maybe we can call. Okay, this is gonna be my output, and after that I want to convert this output to the result image. So what I'm expecting now, the same result is needed to be seen on the output imshow. Okay, you see they are same. What we did now, this is our input, we converted this to the float type in here, and after that we applied logarithmic function. Then we inversed it by applying exponential function again, so it's inverted, then converted again to the unsigned chart type in here, so we get the same result in the output. You see in here, yeah. So in here which we learned already, convert the function, exponential function and logarithmic function, and we used all these three functions in the same example. See you in the next videos.